Okay, Assalamualaikum and good morning. Okay, so we recall. First we recall. Okay, last class we learned about the current voltage relationship in star and delta connection. Okay, for star connection, okay, for delta voltage, the line voltage is equal to phase voltage, and for the star current, okay, I line is equal to I phase current. Phase current. Okay, you need to know which one is the same, which one is not. But for the voltage, is not the same. The relationship is basically V line is equal to V phase square root 3 angle 30 degree. Okay, don't forget to multiply. So for example, if you have you want to find the VAB, basically you need to use the V. Okay, V is the same, V phase. Okay, V phase, or you want to use the VAN. Okay, just to be clear, you have to make sure. Okay, this one is A, this one is B, and this one is A. Okay, make sure the notation is correct. Okay, and angle theta degree. Okay, so make sure this one and this one is the same. Okay, VAB, you have to use VAN. So be careful. Same, but for current in delta, okay, if you look here, the current in delta, so the relationship is almost the same also, which is I, L. Line current is equal to line, phase current, okay, multiply by square root 3, but the angle is negative 30 degree. So you have to be careful. This one is positive, this one is negative. Okay, so be careful with the notation. Okay, and how to use this formula? So basically, for example, the I line is I A. Okay, so IA is basically equals to IA B. Okay, multiply by square root 3 theta negative 30. So you have to make sure this is the same. Okay, so this is from the last class. And also how to derive it. So sometimes the theoretical question asks how to derive this. So how to derive this? If you use for star voltage, okay, so you have to use the VAN, okay. Always this one use the phase, okay. VAN equals to V angle 0 degree, okay. VBN equals to V angle negative 120 degree. Okay, positive sequence, make sure you use the B one. Okay, and use the phase. And VAB equals to VAN minus VBN. Okay, so A, B, B. So use this step. And then insert the value. So equals to this one is just VAN minus this one change to VAN. Use your calculator, you get 0.5 minus 0.86 if not mistaken. Okay. So basically VAN and VBN is the same value. So V, okay, VAN equals to VBN. Okay, VAN equals to VBN just equals to V. So or you can use VP, okay, because this is the phase voltage. So this one is just 1 minus 0.5 minus 0.86. Okay. Okay, let me check first. Yes, this one. Okay. And then lastly, you get VP square root 3 angle 30 degree. So that is how you derive star voltage. Okay. How about delta current? So for delta current, almost the same step. Okay, you need to know how to derive this because it will be asked in the theory. Okay, so same goes. Okay, use phase. Okay, for phase, for delta current, the phase current is okay I AB equals to I AB angle 0 degree. Okay, just assign it. Okay, and because this is balanced load, so you just assume that IBC is 120 degree apart. So make sure positive sequence ABBC, ABBC, CA. So I suggest you start with OI AB. So same with here. Okay. So if you want to know where is this, is in the slide here. Okay, how to derive this. Okay, wait. Okay, this one. Okay. So how to derive this? So basically, okay, if you can see here, okay, and sorry, I forget here, IBC. For this case, for delta current, you have to write ICA also. ICA angle 120 degree. Okay. Or you can use ICA angle negative 240 degree. So basically this one is same. Okay. So how to derive this? So to derive this, okay, I A okay, IA equals to I A B minus I C A. Okay. So you have to make sure if you want to get IA, okay, if you want to get IA, make sure at the beginning this is the A and the end this is the A. Okay, make sure you know to get how to get the delta current. Okay, make sure you choose the correct one. Okay, this is the relationship. Check the red color. So same step. Okay, IA is just basically I Okay, because this is a balance load. Okay, this one is equal to this one. Okay, so balance load is, I just press is IP. Okay, IP, or you want to choose IAB, still also can. Okay, this one is 1 0, 1 angle 0 minus, okay, 1 angle 0, this one is 120, 1 angle 120. Okay, so use your calculator. Okay, and then you get IA equals to IB, okay, multiplied by square root 3 angle negative 120 degree. Sorry, 30 degree, negative 30 degree. So this is how to derive it. Make sure you know how to derive both of this, and make sure you know the relationship. Okay. Okay, this is the derivation. Basically, I just explained. Okay. Also, okay, this one. Okay, if you can see here. Okay. So, like I said before, if IA beginning A and A. Okay, and if for B, B and B. Okay, and for C, C and C. Beginning and ending. So you have to be careful. Okay, and make sure you know how to draw this. Okay, so just copy back. Okay, so for red one is I1, IAB is the phase current. Phase current usually much more smaller. Okay, same as voltage here. Okay, this one doesn't show. Okay, this also show for voltage. Okay, for phase voltage is small. Okay, and make sure it's 30 degree apart. Okay, make sure you know how to draw this. Okay, basically you just draw back what you have calculated. Okay, this one also phasor diagram. So make sure you know how to draw this back. Okay, this one is IA, IBC, IBC, and ICA. Okay, so for this one is IA, the line current. This one IB and IC. This one. Okay, make sure the angle also. This one just recall back what you have learned in chapter 2, which is phasor diagram. Okay. So as I showed before, there are star and delta. Load, there are star and delta for generator and load. Okay, the same concept here. Okay, and the one thing you need to know is this one. I also show you last week. Okay, so if you want to calculate the current, okay, the current, make sure that you use the phase. Okay, make sure you use phase value. Okay, don't use line value. Okay, for voltage, make sure you use phase voltage. Okay, because phase because it's balance load. Okay, the Z is the same. ZA, ZB, ZC is the same. Okay, this one also already shown before. And this one is if the system is balanced, IN is equals to 0. So that's why you don't need the line current. Okay, the 4-wire type. Okay, the neutral current don't need. Okay, because for balance load, if you plus everything, it's equals to 0. Okay, same here. Okay, this one should be N. Okay, S also is not a standard form, but usually you can use also. Better to use VAN. Okay, same here. Don't forget to use phase. Okay. Okay, for this one, okay, for delta, that one is for star, this one is for delta. For delta, also phase voltage. Okay, don't forget, always use phase. Okay, I give you example again. Okay, give a balanced three-phase four-wire system with Y connection. Inductive load whose series impedance is Z equals to 4 plus J4 per phase. And the supply voltage is 415. Okay, what it means by supply voltage, remember, this one is automatically you assume V line. Okay, always assume it is a V line. So again, I show you example. Okay, when you want to answer your test or exam, okay, your exam, make sure you draw again, okay, the system, okay. So calculate the phase current, phase and line voltage. So, okay, wait. So first you start with line voltage because it's already give the line voltage. Okay, so you just assign it. VAB, okay, VAB is equals to 415 angle 0 degree, and then you assign the others. BC, okay, positive sequence A, B, BC, C, A. 415 angle 100 and negative 120 degree, and this one is line voltage. Make sure you set what is this. Okay, if not, you can lose mark. Make sure you tell what is the line voltage, what is the phase voltage. VCA, okay, equals to 415 angle negative 240 degree. Okay, that is the line voltage. How about phase voltage? Okay, for phase voltage, use the formula. So how to change it? V line is equals to VP, okay, square root 3 angle 30 degree. Okay. So how sometimes students forget flip it. Okay, V line and V phase. So assume that this is all multiply. So basically, remember L, M, N, O, P. So L start first, then P. Okay, J, K, L, M, N, O, P. So how do you remember? L start first, then P, right? So L, P. Okay, that is how you memorize the formula because this formula is not given in the final exam. Okay. So use this formula again. Start with the line, and then VP is equals to V line equals divide by square root 3 angle 30 degree. Okay, this is the formula you will use because this is the line voltage. You have to insert the line voltage here. Okay, so the first phase VAN. So the phase voltage VAN is equals to 415 divided by square root 3. The angle is 0 minus 30 degree. Okay. So I move here. Okay. So 415 divided by square root 3 is 239.6. Okay. The angle is negative 30 degree. Okay. VBN is equals to, okay, the same here. 415 divided by square root 3. Angle is, okay, if you check back, what is VBN? Okay, remember you use this one because VBN, so you have to look VB. Okay, VBC. Okay, remember, like I said before, look at here and look at here. Okay, so the angle is negative 120 degree, negative 120 degree minus 30 degree. So you get, okay, 239.6 angle negative 150 degree. Okay, and VCN, of course, 415 divided by square root 3. Okay, negative 240 degree minus 30 degree. Okay, you get 239.6 angle negative 270 degree, or you can use the other way around, 239.6 angle 90 degree. Okay, remember this one is just plus 360. Okay, the answer is still the same, just your preference. So you obtain the phase and line voltage. So you already get the phase and line voltage. Now find the line current. Okay, so to answer this, the line current, so line current, how to get line current? Okay, and remember the star connection, I line is equals to I phase. Okay, so for IA, okay, the line current IA is equals to, remember the formula, VA and, okay, use phase. Always you use phase when you divide by the impedance. Okay, remember? So the VAN is 239.6, angle is, if you look back here, this one, okay, the angle is negative 30 degree, and then divide by the impedance given in the question, Z is equals to 4 plus J4. Okay, four plus J4. So what is the answer? You use your calculator. Okay, 239, the angle is negative 30 divided by, don't forget bracket, 4 plus 4i. Okay, and this is current, so you have to use the polar form. Okay, so 42.23, okay, 42.2, okay, 42.25, okay, and the angle is, okay, and the angle is negative 75, okay, degree. So you get the first line current. IB is equals to VB, okay, and divide by Z. So 239.6 angle negative 150. Okay, you get from the second here. So again, divide by 4 plus J4 equals to 42.25. Okay, the angle is, okay, make sure it is negative 120 degree apart. So angle is, if you calculate this, you will get negative 195 degree. Okay. Make sure it is negative 120 degree apart. If not, your calculation is wrong. Okay, and lastly, IC is equals to CN divided by Z equals to 239.6 angle negative 190 degree, okay, divided by 4 plus J4. So remember, if you look here, the amplitude is the same. For balance load, make sure the amplitude is the same. For 2.25, angle is, so this one is, so maybe I just use your calculator. Okay, 239.6 angle 90. Okay, 90 degree is from here. Okay, and then divide by 4 plus 4 r, close bracket. And don't forget rectangular form, polar form. So 45 degree. Okay, if you look here, it is 120 degree apart. Okay. So that is how. Is it 120 degree apart? Okay, okay. Okay, it's okay. Just this is how to do it. Okay, and you answer the line current. Okay, this one demonstrate that the neutral current is 0. Remember the formula? Okay. So IN equals to IA plus IB plus IC. So you just add everything together. Okay, just add it, and the answer should be 0 for balance load. So that is how you answer this question. Okay. So make sure you know how to answer this. Okay, don't forget to know how to draw the phasor diagram. Okay, so phasor diagram is here. If you look here, okay, this one is VAB, VBC, and VCA. So all is 120. This one is negative 120 degree. Okay, this one is 415, 415, and 415. If they ask you to draw the line voltage, you just draw the phasor diagram. And sometimes they ask you to draw both. Okay, the line and voltage and the phase voltage. So you have to draw both. So this one is VA, and this one is VBN, and okay, this one is VCN. Okay, make sure it is shorter because the magnitude is much more small. VCN. Okay. So this one is okay, 30 degree. This one is 90 degree, and this one okay is 150 degree, negative 150 degree from here. So make sure you know how to draw the phasor. Okay, if they ask you to draw the phasor diagram, make sure you know how to draw it. Okay, this is how to, oh, now it is power. Okay, for power, I will teach you next week. Okay, but next week is study week, right? Mid-sem. Hello?
Yes, Doctor.
Wait. I think there are internet problem. Wait, Okay, so next week is we have what we mid-sem. Okay, we have mid-sem break. So there is no class for next week. So for week 9, we will learn about three-phase power. Okay, it is easy actually, simple. Okay, and how to measure the three-phase system. Okay. Okay, for now, I just give you another example. How about delta connection? Okay, I give you another example, delta connection. So, okay. So remember how to draw this? Okay. So make sure you know how to draw the delta and star connection. Check the previous video. So this one is A, B, and C. So make sure you know how to label it properly. So plus VAB minus, okay, this one is plus, this is minus VBC. Okay, remember this one is positive, this one is negative. Then VCA. Okay, so C is positive, which is this part. If you look here, okay, this is C. Okay, this is C. So for C is positive, A is negative. So that is how you label the voltage. How about current? Okay, current positive sequence is IAB. So for generator is IAB is basically it goes from B to A for generator. Okay, for load is, okay, this one is A, this one is B. So if IAB is like this, IAB, so the current goes from A to B. So make sure you know the difference. Okay, phase current and for current in line in the generator and load is different direction. So this one is C. So I C, okay. So IBC, okay, positive sequence, and then ICA, ICA. So from C to A, and this one is inverted. So this one is A, this one is B, this one is C. Okay, so IAB, IBC, okay, IBC. So IBC. So from C to B, it is different direction. Okay, and make sure you don't put this. This one is, I just want to show you the direction of the current. Okay. And then this one is ICA. Okay. Don't forget to label the line current. So this one just follow the phase. So IA, the line. Okay. This one is IB. This one is IC. Okay, and then this one is, remember, this one also follow. So plus minus VAB. Okay, this one VBC. Okay, B is positive. Okay, this one is negative, and then VCA. C is positive, and then this one is negative. Okay, so you have the label properly. Let's say this question asks the supply. Oh. Okay, the supply voltage, okay, is 120 volt. So means that this is line voltage is 120 volt. This one is not shown in the slide. Okay, so make sure you remember this. Okay, line voltage is 120. If they said that the supply voltage, okay, is 120 volt. Okay, make sure you know this. But if they said that the voltage source is 120, means that the voltage source, this is the voltage source. Okay, make sure you know the difference. Supply voltage means that the line voltage here and here. Okay, so what you need to do is, usually the first question will ask what is the phase and line voltage. Okay, line and phase voltage. So for delta connection, VL is equals to VL, VP. Okay, line voltage and phase voltage is the same. So therefore, line voltage and phase voltage, okay, make sure you write it. Okay, if not, you are considered wrong. Okay, there will be no mark. So V A B, okay, equals to for 120 voltage angle 0 degree. So VBC is equals to 120. Just use back this value, but the angle change 120 degree. Okay, 120 degree, and then VCA, of course, 120 volt. It is 120 degree. And negative, sorry, positive. So you answer the first question. And then next question is, for example, find line and phase current. Okay, find line and phase current. So how to find current? So basically, remember the formula. So I phase is equals to V phase divided by Z. Okay, remember this formula. Make sure phase. Okay, this one is phase. So how to use this formula? So okay, there are two types of current, either at generator or load. Okay, the current is the same because this is a balanced load. But for unbalanced load, the current is different. So doesn't care. So just okay, if you use this formula, this one is basically at load. Okay. So AB equals to Z, V AB divided by Z. Okay. So Z we don't give yet. Okay, there is also a popular question. Okay, for example, they give something like this. Okay. So you have R and L. R and L. R and L. So if they give like this, you have to calculate it. For example, R is 4, this one is 3, 3J3. So make sure you know how to calculate this. Of course, it is parallel. So Z is basically, okay, Z is just, okay, 4 parallel with J3. So 4J3, okay, divided by, okay, if this happen, they don't show you this one, they just show you this, you have to calculate it yourself. So 4 plus J3. So you get okay, this one is 1.44 plus J 1.92. Okay. So make sure if they give like this, don't panic. Just solve this. Okay. So here is the 120 angle 0 divided by okay, 1.44 plus J 1.92. Okay. So make sure you know how to get the Z value if they don't give it. So this one is 120 divided by 1. Open bracket 1.44 plus 1.92 I. So don't forget rectangular form. So this one is 50 angle negative 53.13 degree. Okay, same here. For IBC is equal to VBC divided by Z. Okay, remember BC, BC. Okay, and then you get 120 divided by 1.44 J 1.92. Okay, you get 50. Remember, balance load is the same. Okay, and the angle is 120 degree apart. Negative 53.13 minus 120. You get negative 173.13. Okay, you can use this one. Okay, this one is negative 120. Sorry, 120 degree. Okay, and then lastly, and once CA is equal to VCA divided by Z, you get 120 angle 120 degree positive one. Okay, this one is 1.44 J. This one is plus plus J 1.92 equals to 50. So use your calculator again. 120 angle 120 divided by 1.44 plus 1.92 I. So don't forget open and close bracket and rectangular form. So the angle is 66.87 degree. Okay. So you get the phase current. How about the line current? Okay, this one is, don't forget to write phase current. Okay, phase current, and then this one is line current. Okay, how to get line current for delta? So basically, IA is equals to IAB minus ICA. Remember this one, A at the beginning, A at the end. So make sure you know how to do this. Or another way, because this is a balance load, okay, so you don't need to use this. Okay, if you don't want to use this one is much more complicated. So because it is balance load, you can use a more simple formula. So a more simple formula is IA is equals to IAB, okay, IAB square root 3 angle negative 30 degree. So this one still okay. This one is for balance load. Okay, because you use a balance load, no need to worry. You just use the this formula. If it's not a balance load, you have to use the previous formula. So what is IAB is 50 what do you call? Okay, 50 angle 53.13 13. Okay, this one. Okay, negative 53.13. Okay, multiply by square root 3, 30. So the IA is 50 multiplied by square root 3, you get 86.6. The angle is negative 23.13. So you need to know how to get the line current. How about the phase current? The line current IB. So IBC. Okay, remember? Okay, remember the notation. Okay, square root 3 angle negative 30 degree. So IBC is negative, okay, 50 angle negative 173.12 square root 3 negative 330 degree. Okay, so this one is the same. Remember, balance load always the same as before. The magnitude, only the phase is different. So negative 177.12 minus 30, you get 207. But if you don't prefer this, you can just add 360. So 152.88 degree. And then lastly, YC is equal to ICA. Square root 3 negative 30 degree. So this 50 angle is, check back. Okay, angle is 66.87. 66.87 degree. Square root 3 multiplied by square root 3 angle negative 30 degree. Okay. So you get, okay, this one is 86.6.
Doktor,
Okay. Yes.
yang IA tu 30 degree ada negatif kan?
Yang mana? IA.
Yang 30 degree.
Ya. Ada negatif. Okay. Oh, so salah lah semua. So repair this So this one is, where is it? 83.13. Okay. So for this one is, okay, this one is correct. Okay, only this one. Okay. So this one is 66 minus, okay, 66.87 minus 30, you get 36.87. 36.87 degree. Okay. That is how you get the line current. And sometimes the question asks you to draw the phasor diagram. So first, how to draw the phasor diagram? Okay, if the draw, okay, they usually don't ask you to draw, but sketch phasor diagram for line and phase voltage. Current. So if this happen, okay, you have to draw everything. So make sure you draw all. So start with the line current first. Or phase current, either way is the same. Okay, so 50 negative 53, so somewhere like this. Okay, 70, this somewhere like here. Oh, make it short. Okay, look at the magnitude, and then 66 somewhere like here. So this one is the reference. Okay, so this one is 66 negative 53.13. Okay, this one is 66.87 degree, and this one is 173.13. So this one is IAB, IBC, ICA. And then draw a IA. IA is 83. So somewhere around here. Make sure it's longer because the magnitude is larger. IA. And this one is 105.2. Okay, this one is around here. IB and IC is around here. Okay, IC. And make sure you put the label. Okay. Okay, drawing pad is not very accurate. So make sure you put the angle. So this one is, where is it? Okay, 83.13. Okay, 83.13. Okay, make sure you label everything. So this is example for, okay, this is example for delta delta. Okay, how about star delta? Okay, for star delta, you have star as a load, as a generator. Okay, so this one and delta as a load. Okay. Okay, there also delta star. Okay, make sure you know how to do everything. Okay, and sometimes they only show you there is no load. Okay, only there is no generator, there is only load. So make sure you know how to solve this all. So you will learn this on your own using assignment 1. Okay, if you look at assignment 1, the mark is 10 mark. Okay, 10% of your final mark, or total mark. Okay, 10% of your total mark. Make sure you answer it. So the assignment 1, I give you the answer, and you have to solve it. Okay, solve every types of connection. So if you don't get the answer, okay, means that there is something wrong with your calculation. So make sure that you know how to do this. Okay. I think that's all for today. Okay. I see you in 1 more weeks, or 2 more weeks. Weeks 9. Okay. So for those who still don't mark your attendance, do so. Okay, and thank you.
Thank you, Doctor.
Thank you, Doctor.
Welcome.
Thank you, Doctor.
Okay, welcome.
Thank you, Doctor.
Okay, welcome.
Thank you, Doctor.
Okay, welcome.